All right, jumping back in, we're going to talk very briefly about designing a program to use functions. This is a little bit more advanced than sort of where we're at this point. We'll probably get there at the end of the semester, but at least this gives you a little bit of an introduction to sort of how you could think ahead in terms of the design of your program. Now, again, as I mentioned in a previous video, it's not the best to just get together and build a house, right? You want to have some sort of a design. You want to think about how this is going to work out. Same thing with a program. You want to be able to have some sort of a sketched-in design to know what direction you're taking in terms of how you're going to create your program. So again, in this particular instance, we're going to be designing a program to use functions. Previously, we were saying, hey, we're going to take user input for age. We're going to take user input for name. We're going to take user input for height. We're going to take user input for the height of the room, the length of the room, the width of the room, and then we're going to go ahead and multiply that all out and get the area of the room. Okay, so we were just doing that all on the outside level. Well, now we're actually thinking about using functions and modularizing it. So that means that we have to have this main method, which is our starting point. Okay, so I want you to think about this main method right here as our starting point. Okay, so every single program that you create, you want to start with a main. Okay, now I'm going to give you a little bit of a hint. This is a little bit of a foreshadowing, but I want all of you to do this, and I want you to get used to it. If you start typing main, M-A, in PyCharm, which I want you to do, if you're not following along with me right now, go ahead and boot up PyCharm and do this. Just all you have to do is type M-A and hit enter. It creates this if name __ name equals main. And then in here, you just type main. Okay, so what this is going to do is when you run this, it's going to say, hey, is this running by itself, which is everything that we do in Cyber 101. We run everything by itself. We're not going to be doing object-oriented programming, okay? But this is Python standard. Python standard. If you're going to be coding Python in a job, if you're going to be coding Python for any sort of professional applications, if you're going to be coding Python for fun, you must follow this convention. Okay, so you open a new Python file, you type MA, you hit enter, and then you type main. Okay, now once you've done that, push that down a little bit, type def main, and now you're ready to actually start coding. Okay, so again, I want you to do this with me. I've just created my chapter 5 Py. I'm going to type MA in PyCharm. I'm going to hit enter, and then I'm going to type my main call. So this is there's nothing weird about this. It's just if name is main, which it will be when you hit the play button, it's going to call the main method. Okay? And right now I don't have a main method, and it's mad at me because you see this red, right? It's like where's the main method? I don't have a main method. Okay? So now I need to go ahead and put that main method up here. Okay? So I have my main method, and I can just do a pass for now, right? So it's going to work. All right? So when I execute this, nothing's going to happen, but it works. Okay? So I want you to do this for all of your assignments. You're going to do if name equals main, call main, and then jump into your main method. And everything starts from your main method. Everything. From here on out, because of this setup, I don't want to ever see any function calls out here at this level. I don't want to see any variables out at this level. Okay? I want to see everything inside of these functions. Okay? Just so you're aware of that. So this right here is the main method, and this is the way that we execute that main method should we run it on a standalone. Okay, so again, do that over and over and over and over again. Very good at it. Get very good at it. All right, so in terms of how we design this function, we start with the mainline function, which is the main method, right? And then that main method sort of is the jump off point. So everything starts from here, and from here it sort of branches out. It can go over to this function and to that function and to some other function, and that function can call another function. And it can really branch out. And so the way that we can model that is using a flowchart, right? So in a flowchart, we can see all the function calls and how they sort of work. Function calls are rectangles, and it's sort of written inside that. Now, this is going to create something called a top-down design. The top-down design is that the main method is the sort of the root, and then everything sort of progresses out from there. Okay, so the way that sort of looks, this hierarchy chart or flow chart, it looks like this right here. Okay, so we start at the main method, and then we can get to get input, calc gross pay, calc overtime, calc withholdings, calc net pay. So we can sort of see how everything can sort of flow through the program. Okay. So again, pretty quick through that because we're not going to have a lot of material on tests and stuff for that, but this is what you're going to be doing. All right, so something that you've already been exposed to is the pass keyword. Okay, so I already have it over here, pass. Boom. Okay. You can use the pass keyword to create empty functions. The pass keyword's ignored when by the Python interpreter, but it makes sure that there's no errors, right? If I want to create an empty function, but I don't have pass, if I go to run it, it's going to give me an error. See, it's having troubles because it's like, well, I'm expecting something to be here, but there is nothing there. What's hard about it is it actually gives you an error that says it's line 5 at fault, when in reality, it's not line 5. It's actually that you're missing something inside of that function. Okay, so now that I put the pass in there, everything's good to go. Okay, so this pass is like a placeholder. Think of it as put a pin in it, or just something that sort of says, hey, something's going to be here, but it's not here yet. Okay, so that's what that pass is. And you've noticed I use a lot of passes with, my if else statements, right? Because I can just say, hey, something's going to be here. I just don't know what that is quite yet. Okay, so that's what that pass keyword is. And it's just ignored whenever the interpreter is rolling through it. All right, so we want to talk a little bit about variables here for a second. Within these functions, it used to be, well, let me back up a little bit. In the iterative process up to this point, through the first 4 chapters, when we defined a variable, we would put it out here, correct? Length 5, height equals 6, width equals 7, okay? So this is what we would call a global variable. Now, the reason why we call it a global variable, and we're going to talk more about it later, is every single function just has access to it. Okay, so the rule of thumb is if the function is defined at this level, it has access to all of the variables at that level. Okay, so in here in this def main, because I made these global, I can actually access those from within the main method without actually passing them in. So I can say print width, right? So I can just print that out. Boom, I have width 7. Okay, so these are called global variables, but we don't really like that, right? Because global variables can get really out of hand. Because what if 2 functions are trying to change the same variable at one time? What if it's 10 functions trying to read and write to the same variable simultaneously? It gets to be a really, really big mess. So instead of using global variables, we use things called local variables. Okay, these local variables are variables that are assigned inside of a function. Okay, so it belongs to the function in which it's created, and it cannot be accessed from outside that function. So only statements inside the function or below it can access it. Okay, and what this is doing is this is beginning to introduce us to a concept called scope. Okay, so scope is what is available, what can actually access this particular thing. Because believe it or not, I can actually create definitions inside of other definitions, okay? And then the scope changes inside of that, okay? So if I now had, var a here as 10, this def print thing, oops, make sure that's an underscore. This def can actually now have access to that variable. Okay, so now you can do this. I'm just making a statement. I don't ever want you to do this, but you can do this, and then this could have access to this, right? But some other function down here cannot have access to this because this is only available in the main method. Okay, so this is a local variable. A local variable is only available within the function that it is declared within. Okay, so again, scope, the definition is the part of a program which a variable may be accessed. Okay, so let's make a couple of test functions here, and they're just going to kind of be dumb throwaways. So we're going to have print. Let's just do add 2. Okay, and we're going to have a variable called var a and var b. All right, and then we're going to have var c is 2 plus 4 plus 2. Okay, so again, this is a throwaway function. It's not really doing anything, but you can see I have these 3 variables here inside of this definition. Okay, and now I can come in and I can actually make this happen. So I can print this out. I can print var c. Boom, var c is now printed. Okay, and then I can even make this more simplified by using var a and then var b, and there we go. Okay, so I have var a, var b plus 2, and then I go ahead and print that out. Okay, so now this var a, var b, and var c are what we would call local variables. They are local to the def called add2. I cannot access those variables here in main. And just to show you that I can't, let's just go ahead and try to print var a. Okay, it's going to be mad at us, right? Because I cannot access it. I can only access it from the inside. So it says name error var a is not defined. Now, if I change this and I say let's print var c, we're going to get the same error, right? Because it's not a local variable, right? Now, if I move this, well, actually, I don't even move it. I can delete it, and I can instead do this function call, and I can function call from my main method. Okay, so if name equals main is where it starts. It says, okay, name is equal to main, call main. So it calls main. It prints out the width, which it's printing that 7, and then it says, hey, go to the function called add2. It jumps to the function called add2. It says var a is 2, var b is 4, var c is var a plus var b plus 2, and then it's going to print var c, and then it's going to return back to this line right here. And that's where we're going to see happen. So now we're actually going to be able to print var c. 4 plus 2 plus 2 is 8. So we have var c available to us. Okay, so these are called local variables, and the scope of these local variables is only in the function called add2. Okay, so that's kind of what we mean when we're talking about scope. Obviously, these are global, these are local. The scope of this is everything. The scope of this is only within add2. All right. So continuing to move through some of our local variables. Again, they cannot be accessed by statements inside which precede its creation as well, which is sort of how it's been in the just coding in general, right? I can't reference a variable that I haven't declared yet, right? So I can say print var c, right? And it's going to be like, what's var c? Because when we follow the program logic, it says, okay, if name equals main, which it is, call main. Okay, so we're going to jump to main, and then we're going to jump and we're going to print the width. We're going to call add2, so we're going to jump into add2, and then we're going to print var c, and it's like, well, what's var c? I have no idea what var c is because var c hasn't been declared yet, right? Hasn't been declared or assigned. So it's going to throw an error. So we have to make sure that we print var c after we actually initialize that variable. Okay? So again, local variables can't be accessed by statements which precede its creation. Okay? So obviously you're going to have a bunch of different local variables, and inside of those different functions, you can actually have variables with the same name. So I can actually have length, height, whatever, var a, var b, var c in some other function. Okay? So I can actually have a def add 3, for instance. Okay, so I can almost be a sort of a carbon copy of this, and I can add 3 here. I can have the same named variables at this point because this is locally scoped and this is locally scoped. Okay, now obviously to be able to get into this, I also have to call add 3. Okay, so again, it's going to come in. If name is main, it is main. We're going to call main. We're going to jump into main. We're going to print the width. We're going to call add2. We're going to assign 2 to var a, 4 to var b. We're going to set var c as var a plus var b plus 2. And then we're going to print that. Then we're going to return back. We're going to call add3. We're going to say var a is 2, var b is 4, var c is var a plus var b plus 3. We're going to print that out. And then we're going to return back to line 10. Okay, so you can see what that program flow sort of looks like. And we get 7, 8, 9. Okay, so that's sort of the way that is. Now, but you've noticed that var a, var b, and var c are in both of these functions, and it's not a big deal. Okay, all right, so we're going to go ahead and stop for a little bit and come back and talk about passing arguments.